welcome. So we're going to do one more problem together, and then I'm going to go over some homework that you'll have. All right, so pictured to the right is the graph of f of x equals negative 1/2 times x plus 1 squared plus 4, quadratic equation, concave down because a is negative, vertex at negative 1, 4, right? Pretty standard kind of graph. We want to draw the tangent line to the graph at f of x equals 1. And then estimate the value of f prime of 1. All right, so you want to just kind of hug your, thought I had a line tool out. And I'd like it to be a color that's not black. Let's see if I have a line tool out now. So I'm going to try to hug the graph at x equals 1. That looks reasonably good. All right, so this appears to be going down to the right one. I go from like a half to 1.5. So I would say that that is a slope of negative 2. So that means that f prime of 1 is approximately negative 2. Find the equation of the tangent line to the graph at f of x equals 1. All right, so of course we need the slope, which is negative 2. And we need the point. I need a point to be able to write the equation of a line. All right, so the x value is 1. If we look at 1, we have the point. I have a recording box here, so it's kind of hard for me to write. I'm going to move the box that you can't see. So that points at 1, 2. So that means the equation of the line is y minus 2 equals negative 2 times x minus 1. We could isolate y, so we'd have y equals negative 2, x minus 1 plus 2. If you want it in slope-intercept form, any of these are good, then it would be y equals negative 2x. That would be plus 2 plus 2, so that's plus 4. Right? And you can see if we can continue that line, it basically go to about 4. The normal line is the line that's perpendicular to the tangent line at the point of tangency. Draw this line and find the equation of the normal line. Oh, pretty orange. All right, so if it's perpendicular, right, that line has a slope of 2. Our normal line should have a slope of 1/2, and it should go through the exact same point of tangency. There we go. So that is our normal line. I'll just put normal line. The purple was the tangent line. The orange is the normal line. All right, so we drew that in. We want to find the equation of the normal line. So, of course, the slope is going to be positive 1/2, and that's because the tangent line is perpendicular to the normal line. And then we have the exact same point, 1, 2. So the equation is going to be y minus 2 equals 1/2 x minus 1. Or you can isolate y, and then it would be y equals 1/2 x minus 1 plus 2. If you want to put it in slope-intercept form, then that would be y equals 1/2 x. That would be 1/2 minus 1/2 plus 2. That would be plus 3/2. All right? Any of those are perfectly acceptable as the equation of the line. All right, so we've done some in context here. So I'm going to have some problems. I have some problems for you to do, and these should be in your notes. So this one is going to be a homework problem for you. This is the graph of g of x. Identify characteristics about the graph of g prime of x. All right, so where will g prime of x be negative? Where will g prime of x be positive? And where will g prime of x equals 0? Right? And when you're listing where, just put it at the x values. Right? That would be fine, because it would be a different y value on the graph of g prime of x, but it'll be the same x value. Notice the arrows. This is going to infinity. So whatever it's doing, where we see the arrows, it's going to keep on doing that. All right, so you're going to fill this in. Don't forget to give a reason for your answer. And the reasons would be, you'd be using the graph, right? And we know that we learned something about the derivative when the graph is increasing, when the graph is decreasing, when the graph has a horizontal tangent, right? All right, I'm not going to say any more, because otherwise I'll end up doing the whole problem for you. This one here is also homework. This time, however, this is the graph of the derivative. So you're going to use the graph of the derivative to describe the graph of the function. And don't forget to give a reason. And you'll see even more reasons in the next lesson, in the next Nearpod, but I wanted to go over it now. And then this one is also homework. You're identifying the characteristics. So if h negative, so you've got a point, h negative 1 is 1/2. What's the equation of the tangent line drawn to the graph of h of x at x equals -1? And yes, it is okay to approximate. If it's a reasonable answer, it's going to be correct. Right? You won't be able to get exact. And then I have a table for you. And I'm going to do a similar problem like this in the next Nearpod. So if you do get confused, watch that next Nearpod, and that should help you out with it. All right, so numerically, the value of the derivative at a point can be estimated by finding the slope of the secant line passing between 2 points on the graph. So this is you're estimating the derivative here with the slope of the secant line. I think you should be okay on this. Right? And whatever you want to say is close to the point as possible. So for instance, for x equals 0, you want to use -3 and 1. Right? So you're estimating the graph here with the secant line, and then you're evaluating it based on that estimation of the derivative, and you're writing the equation of the line using the points that are in the graph, right? Or excuse me, the points in the table. And so you have all the points that you need, and the slopes you estimate with the secant line. Right? I think you should be totally fine on this. And I think that was the end of the homework. Yep. All right, so you'll find these problems in your book. If you're not sure, I'll try to post what pages they're on in the book. All right. Have a nice day, and thanks for watching. Bye for now.